Good morning and welcome. Welcome to the 2025 National Health Research Forum from Research America. Welcome to the headquarters of AAAS. I have the privilege of serving as the CEO of the American Association for the Advancement of Science, an executive publisher of the Science family of journals. I'm Sudip Parikh. And I'm just going to very quickly welcome you here. Thank you for being here. I think we have an exciting agenda today put together by Mary Woolley and the wonderful team at Research America. I wanted to welcome you with just a couple of thoughts. One is that we are living in extraordinary times, and I can put that on any axis, whether it's scientific progress or whether it's scientific challenge. But we meet today on a day that's fraught, and I want to recognize that, and I want folks to take it in. You know, we are going through a time where we're having discussions about the future, and they're getting harder. They're getting harder, and there's a lot of emotion involved, an incredible amount of emotion involved. And one of the things I hope that we can project today is that there are amazing things that are happening. There are amazing things that are not happening because we're dropping the ball, and that there's a group of people, a large group of people, who are trying to do the right thing. And as members of the scientific enterprise, as folks who care deeply about what science can do for people, what it can do for the planet, what it can do for ourselves, for us as individuals, I think we have an obligation. I think we have an obligation to listen to one another, give a little bit of grace, argue vehemently, argue as if our lives depended on it, because frankly they do. Frankly, they do. I firmly believe that we can change the length of our health span and our lifespan with the choices that we make in policy. And so today, I'm so glad to welcome my friend Jay Bhattacharya to AAAS. And I call him my friend because he is my friend. We disagree vehemently on some things, and we argue, and we argue spiritedly. But at the end of the day, he got his MD because he wanted to help people. I got my PhD because I didn't know what to do. And at the end of the day, we are aiming for the same stuff. Everybody in this room. And we have different views about how to make that happen. But I want to encourage us to speak vociferously, argue vehemently, and aim for the same goal. And you know where I learned some of that is from a mentor of mine named Mary Woolley. Mary Woolley is the president and CEO of Research America. She is, I think, someone to both admire and to model behavior for all of us. And so with that, I'm going to turn it over to my friend, Mary Woolley.
Thank you, Sudip, and back at you as a fabulous friend. And these days, in addition to everything else you're doing, also the chair of the board of Research America, which we truly thank you for. It's wonderful to look out into this audience and see so many friends and colleagues. We're a community that matters so much. Matters deeply to me, and I think it matters deeply to accomplishing our mission of giving medical and health research every chance in every sector to thrive, to deliver on its promise to the American people. And that's happening every day, and there's going to be more where that came from. As I thank you all for being with us, I also want to take a minute to thank you. If you are a member, your organization is a member of the Research America Alliance, we thank you for your ongoing support, for your ideas, for your participation and engagement. And we're going to have more opportunities for that kind of engagement after we hear from a couple of speakers this morning. So as we look forward to the rest of this day, I want to thank our sponsors, for whom we are so grateful for their support, not only for this program this morning in this room, but for the ones that preceded it in our full month, really, of programming to help advance advocacy for medical and health research, including some of the poster sessions that you saw out in the lobby, where early career scientists have broken ground in major ways, I would say, in engaging with their own communities, people who aren't science trained, but who live and work and play in their communities, and whom we need stronger connections with in order to assure that research thrives. So I thank Johnson & Johnson, Amgen, Pfizer, Genentech, Cencora, the American Society for Microbiology, the Association of American Medical Colleges, Eisai, Elsevier, Lilly, Picori, Pharma, and Ultragenics. Truly, you all are wonderful partners all year round. So I'm going to now introduce our special speaker for today, and I do that with great, great pleasure and honor. Research America has had the opportunity since 1989 to feature the director of the NIH in a program where our members and friends have the opportunity to hear the director speak about his or her, there actually have been some hers, vision for the NIH. And as I say, that goes back to Dr. Jim Weingarten in the late 80s when Research America was launched. So Dr. Bhattacharya, before becoming director of the NIH, which was just this April, was at Stanford at the med school, where he's a physician, researcher, and health economist. His research focused on population aging and chronic disease, particularly on the health and well-being of vulnerable populations. And I really should emphasize that Dr. Bhattacharya is a longtime NIH grantee. So he knows the agency intimately from being a grantee, from being part of the process of NIH, and now as the leader. So please join me in welcoming Dr. J. Bhattacharya.
Thank you, Mary. Thank you, Sudip. It's been absolutely wonderful to get to know Mary and Sudip and to get to understand sort of the broad coalition of people that make science supported and well-resourced. And it's been, as Sudip said, sometimes we get to talk to each other very bluntly, but at the end of the day, we have the same aim. And that aim is to make sure that the research serves the interests of the people, that to use research so that we make people's lives better. And that's been my career aim ever since I wrote that hopelessly ignorant application for med school almost 40 years, or some number of years ago. I don't remember how many. And so I have a very boring title for this, but actually I hope that the talk is interesting. I have 30 minutes. I told everybody I have 30 minutes of slides for a 20-minute talk, so I will try to talk fast, which is a hazard. Let me just talk slow on this part because I think this is probably the most important part. When I first got selected as NIH director, I asked myself what kind of vision for the reform of the NIH or changes to the NIH would unify people, where we all agree on the shared kinds of problems that we have, so we can fix them so that the NIH works better. And this is what I came up with. I'm going to emphasize the first three because again, I have 20-minute talk for 30. I have 30 minutes for a 20-minute talk. But all five are very important to me. So first, improve population health. I'll show you just a bit, but we are at an amazing moment where there's a broad coalition of people that are asking the scientists of this country to help them live healthier and longer lives. The MAHA movement is, from a political point of view, to me, is absolutely remarkable. To see the real need for better health in this country, to address the chronic health problems that we all know that we all have, see that reflected in a real way in a very broad political coalition is remarkable, and we have to make sure that we understand what the moment means, and to do science that addresses those needs. Second, we have to ensure reliable results. I'll talk a little bit about something that's probably a bit uncomfortable, which is the replication problem. When I was a medical student, my favorite professor would tell me that, Jay, half of what we're teaching you is not true. What would you ask him? What I told him is which half, right? And he was right. So for instance, when I was, this is 40 years ago, you can see how old I am now, but back then, ulcers were not caused by bacteria. They were caused by stress. You remember that? And treated with partial vagotomies. Huge advances in science have transformed how we manage ulcers for the better. Basic science translated over better clinical science than translated into practice. I've seen the capacity for science to do such good, but at the same time, a lot of the scientific literature is documented to not be replicable, and it's something we have to take seriously, and the NIH should take seriously, and I have some ideas for how to make that better. Third, at the NIH, we have to invest in big advances. This is tied actually very closely to the long-standing problems that we know about the difficulties that early career scientists have in getting support for their work, and then transitioning into independent scientific thinking. I'll talk about that as well. Maintaining safety and transparency. There's a lot of reasons to do better at that, but the primary one is to ensure the public that the research we do in the conduct of the research does not pose any risk whatsoever to the public. And in fact, quite the opposite, that it's necessary for us to take this seriously so that the research we do translates into better health and better longevity and better well-being for the public. And finally, to encourage academic freedom. To me, this is very, very important, especially in light of the pandemic. I can tell you from firsthand that we scientists didn't always do the best job at guaranteeing that. But that's something we in our DNA have as the sort of this desire to speak to each other, to learn from each other, especially when we disagree with each other. I want to make sure that I want the NIH to contribute to making sure that kind of space where scientists can have, as Sudip said, vigorous disagreements, but at the end of the day, we share the common desire to know truth. And to translate that truth into better well-being for people, that's I think the sort of my touchstone. And so those are my 5 sort of items where I said to myself, if I can help with all these 5 things, I'll have been a successful NIH director. Okay, now I'm just going to talk primarily about the first 3 things, but the reason is I want to focus on 4 different areas. I could literally go on for much longer. 20 minutes? Or I really only have 20 minutes, Mary? Yes, this is. You invite a professor and give them 20 minutes. It's just not fair. Okay, so let me talk about research to make America healthy. Research to make America healthy. The Maha moment is really, really, really important, because what it means is that there's a broad political coalition that wants the scientific outputs of the world to address their problems. And the problems are real and they're substantial, right? So since 2012, there has been no increase in life expectancy in this country. None. The mission of the NIH is to do research that improves health and longevity. And from a macro point of view, we have not achieved that mission over the past dozen years in this country. There's many reasons for that. And we could go on at length about what those reasons are. In fact, I wrote about some of those reasons in my own research before. There's social reasons, there's medical reasons, there's a whole host of reasons why, the demographic reasons. Whatever those reasons are, science needs to contribute to reversing that. The science that we do needs to translate over into improving the broad population health. The desire for people to have their children be healthier than them, that's real. But there's a real possibility that we face that our children will not be healthier than us. There's huge increases in diabetes, in obesity, heart disease. While cancer mortality has come down, a real triumph of science, nevertheless, the rates of incidence of cancer have not come down. What we see is large-scale problems that have not been addressed by science in a way that actually reverses the negative trends. I want the NIH to focus on those conditions that impact the well-being of Americans at scale. Just as we focus so well on rare cancers, on rare diseases, we will continue to focus on those. Those are very, very important, both for the patients that we are helping with them, but also the fundamental science that's revealed by them. At the same time, the research we do needs to translate over to help address these broad population problems that affect literally hundreds of millions of Americans. And the MAHA movement gives us political allies to do that. Okay, gold standard science plan. The president, a couple of months ago, signed an executive order, which I absolutely love. And I'm just going to read to you the definition of gold standard science, just a few elements of it from this. And I want to, as I'm reading to you this list, you can see it on there, so I'm not reading anything that you don't already see. But ask yourself, is there any single element on this list that you disagree with in terms of what gold standard science should be, what science should be? Okay, so gold standard science is reproducible, transparent, communicates error and uncertainty, collaborative and interdisciplinary, skeptical of findings and assumptions, structured for falsifiability of hypotheses, subject to unbiased peer review, accepts negative results as well as positive results, and devoid of conflicts of interest. Does anyone object? Thank you. I love this. I love this. This is what science is, right? This is what science is about. It's essentially, despite the incredible things that we do with science that do translate over to better health for people, better well-being for people, better lives for people, at its root, science is humble. We leave open the possibility that what we think is not right, and we ask others to check our work. Right? That's what reproducibility means. Transparent means we show people exactly what we did, and let people have their say. All of these items, to me, if we had a culture of science that fully embraced this, we would have a much healthier culture of science. And I think, in many ways, obviously, we do. We hold these as standards, it's gold standard science. But we have to make these real, because in some ways, our science hasn't always met these standards. I'm just going to talk about reproducibility just for a bit. I'm going to launch this replication initiative. In 2005, my colleague at Stanford, John Ioannidis, wrote a paper with the title, the absolutely remarkable title, Why Most Published Biomedical Research Findings Are False. Who's read that? Anyone read that paper? Who's read that paper? It's, when I read that paper, it's 2005, this is, after med school, so I've already was trained to think that half of what I was learning is false. So, it's like, it wasn't such a shock. But, you read it, and it is a shock. And the reason why he gives is because science is hard. That's the fundamental reason. It's not that science are doing fraudulent things or anything like that. It's that science is hard. And the publication sort of standards that we have will necessarily allow scientific ideas that are not true to be published. Why they're not true? Because science is hard. It's very easy for scientists to convince themselves that they have the answer for some problem. We can even do statistical tests and all this stuff and then get it published. And yet, when independent people later look at it, it turns out not to be right. Actually, ulcers are caused by a bacteria. They're not caused by stress so much, which is what I learned in med school. And there's nothing wrong with that. Science being hard is normal. So you have standards in scientific publishing that guarantee that there will be scientific results published that are just not right. And now there have been a whole set of follow-up studies in cancer biology and psychology and field after field after field that finds that a lot of published biomedical results, when independent people look at it and try to replicate the results, do not find the same findings. Up to half or 2/3 in some cases. Now, on the flip side, vast amounts of science that we know for sure is never published, right? So if you have a negative result, who has papers in their file drawer of results, of null results that they have no chance of publishing? Like, every scientist should raise their hand to that. Every scientist has had ideas, you try it out in the data, it doesn't work out. And you can't tell anyone about it because you can't publish it. And so you have a scientific literature that is frankly misleading. Results, positive results that turn out in replication, they're not to be true, and large numbers of negative results that are true that can't be published. Okay, so how can the NIH fix this? In my view, there's three structural problems. First, it's difficult for scientists to do this kind of replication work, reproducibility, generalizability, falsification of hypotheses, meta-analysis for a living to get support from the NIH. And I'm going to fix that. We should make a cadre of scientists whose job it is, whose work it is to look at the scientific literature and ask, is it true? Now, what I want is the scientific community itself to decide what are the sort of the rate-limiting steps in science that we know need to be checked in order to make advances. I've talked to so many drug developers who tell me that they will do their own replication efforts before they invest millions of dollars in their science, in the next steps in their science, because if they don't do that, they'll be basing their investments on things they don't know to be true. So we have a situation where large private organizations understand which parts of the relevant scientific literature are true and false, at least replicable, I should say, whereas the public at large doesn't. And that's something we can and will fix. By giving awards so that researchers who do this for a living can get promotions in their universities, can get the kind of honor that they really do deserve, because they're such a fundamental part of science. Second, we need a place where you can publish your results. If you have negative results, you should be able to publish them. If you have replication results, you should be able to publish them. I'm going to establish at the NIH a repository for these kinds of results, and then link them to the scientific literature. Imagine you do a PubMed search, you've got a paper that comes up, and you have a replication button. You click the replication button, and then you can see all the relevant replication efforts that have been done on that paper. And then you can go, they'll have links, so you can go read them yourself and do your own evaluation. We should make replication the standard for deciding what is true and false in science, rather than just simply publication in a top scientific journal. Right? The publication in a top scientific journal is a marker of truth, but think about this: is it actually truth? What we want is to encourage a scientific culture where we read the papers, read the replication efforts, and make up our minds about what's true. That's really what we want. Okay, and then third, we need metrics that reward scientists who act in pro-social ways. What do I mean by that? Do you share your data publicly? Do you share your code publicly? Do you share your tissue samples in a biobank? Do you list your methods out in a way so that other independent teams looking at it can follow the same steps you did? Or do you have secret sauce somewhere in there that you didn't say, right? Because you're scared someone will scoop you. I want metrics for scientists who behave in pro-social ways, and something we can do. There's a whole field of science that's devoted to this, actually. And the idea is, if you measure it, you can change the culture of science around it. Right now, the two metrics primarily that we use, sort of the dimensions we use to measure the productivity of scientists, one is how many publications you have, and then two is what's your influence, how many citations do you have. But I submit to you that that's too narrow a set of metrics to decide the productivity of scientists. We absolutely need to have metrics that reward other aspects of scientist productivity that we all want. I'm calling it pro-social behavior by scientists. We want to measure those things, because if you measure it, you provide incentives for it, people will do it. Okay, third, I'm absolutely committed to support for early career investigators. Let me show you a couple of depressing graphs. I'm a health economist. Economists tend to show you bad news. Let me just show you the bad news up front. This is the average age of the first-time R01. All you in the room know, but R01 is the first large is the large grant. It's like the showpiece grant. Very often, universities will require you to get a large grant in order to get promotion, right? To get tenure. The age at which the NIH awarded the first R01 has been increasing for decades. If you look back to 1980, the first large R01s were awarded to scientists in their mid-30s. Now, we're talking in the mid-40s. It's very typical for the first large R01 to be born in the mid-40s. We've created a culture in science, in biomedicine at least, where we require you to have 1, 2, 3 postdocs before you have any chance of getting support from the NIH. We've extended the period before which young scientists can try out their ideas. We've essentially told them that you need to wait your turn. If you look at this is even more depressing. This graph. So this graph is the years since an F32. Where F32 is a fellowship award that we give to young scientists, right? And what this is a Kaplan-Meier curve asking time to drop out of science. Now, of course, as people age, they may go on to do other things. That's normal. So you see the sort of step function in sort of engagement with science over time. That makes sense. I want you to focus on the left side of the graph, though. Focus on the left side of the graph. And the question is, what fraction of the young people that we support with these training grants stay in science and just leave science within the first couple of years, first 2 or 3 years? In the 1970s, that blue line, that fraction was about 10 to 20%. 10 to 20% would get support from us, and then they would go do something else with their lives. The orange line is in the 1980s. It jumped up to 25%. In the 1990s, it jumped up to 40%. In the 2000s, it jumped up to 50%. And now, fully 60% of the people we support F32 grants within 2 years are out of science. We punish failure too much, especially for early career researchers. We make it too difficult to. I want to contrast it with Silicon Valley, where you can have you get a VC funding for your small company. The company does its best, but it just fails. That's normal. Most new companies fail. But then because it's a constructive failure, you can go get more support. You can try your ideas out again and again. What this evidence suggests is that we don't allow young scientists to fail constructively. Actually, just as a test of that, how many of you all have failed projects in your drawer? How many have published those failed projects? The culture of science needs to do better at that, right? We need to not punish failure so much, and let me tell you why I think it's a problem. Why it's a fundamental problem. There's lots of reasons, but one of the reasons. This is a paper I published with Mikko Pakalin and in 2019. What we did is we looked at all of the words in the published papers in biomedicine in 1940. All right, so just take all of the papers published in PubMed in 1940, index every single word and word combination in them, and then do the same thing in 1941. If you subtract out the 1940 words and adjust for synonyms, what you're left with is essentially all the new ideas that were introduced in 1941. Used in 42, 43, 44, 45, go out forward, and you have a whole history of biomedicine just pulled out of the words published in PubMed. Then, now that you know the age of the year in which every single new idea was introduced, you go back to each paper and ask, what's the age of the newest idea in every single paper? All right, so that's the key sort of metric that we developed, Mikko and I. And then on the x-axis is career age. Career age is, we're just using PubMed, is the years since you first published, you published your first paper, right? That's indexed. If you look, for me, it's 1996. I am now 29 years old, you guys. The only metric in which I'm 29. I'm much older than 29. But career age is 29, right? Now, here's the depressing result. The depressing result is after the first 2 years after your first publication, that's when you're most likely to have the newest ideas in your paper. And for every year of career age, the age at which your ideas in your papers age by about a year. Nobel Prize winners, when we look at them, 2 years of chronological age, the ideas in their papers age by about a year. They're trying valiantly to stay up, but it's really young people that are the font of these new ideas, that are the heart and soul of scientific vitality. And we're not giving them the capacity to try their ideas out. Just to make everyone in the room feel better, especially me with my gray hair, this graph shows a heat map. The x-axis is the career age of the first author of a paper. The y-axis is the career age of the last author, usually the senior author of a paper. It's that combination of early career scientists in the first 10 years of their career, x-axis, paired together with researchers later in their career, 10 to 30, could be longer, where you see that deep red, which is the pairing that's most likely to have newer ideas in their paper. So team science matters. I'm not saying that we should just have only a youth revolution in science. It's obviously the pairing of older researchers and young researchers is really, really important for trying out new ideas and for all other measures of productivity. What I'm saying is that we need to do better, and it's in the recent past, the 1970s, where we allowed where we allowed early career researchers to have a chance, and that's what I'm aiming at. Max Planck once said, very famously, "Science advances one obituary at a time." I want to make sure that we don't need that for advances in biomedicine. We don't need that. That biomedicine as a culture is open to new refreshing of new ideas. Okay, finally, and then I promise I'm done, the unified strategy to fund projects. Okay, so let me give you a couple more depressing graphs, and then I'll tell you how we plan to fix it. I published this paper again with Mika Pakalin a couple years ago, I guess, oh my God, 5 years ago, on NIH funding the pursuit of edge science. Let me just show you the sort of the key finding. The x-axis is the age of the newest idea input. I already described how we got that. The y-axis is the fraction of papers that have, for instance, the top left graph, part of this graph, is the age of is the fraction of papers that have 0-year-old ideas in them that have NIH funding in PubMed. And this is for every single paper published between 1990 and 1999. You would expect a graph like this, right? So 55% of the papers that had 0-year-old ideas in them had NIH funding for this cohort of papers. And you expect there to be a decline because the NIH very much prioritizes innovation, right? We want to fund the newest ideas, even if they turn out to be wrong in retrospect. That's the only way science goes forward, is by investing in newer ideas, seeing if they're right, and checking them. With the replication efforts that we, of course, talked about, that it dovetails really nicely. So you expect to sort of a declining, this graph to decline as the age of the newest idea input goes, and that's exactly what you see in the papers that were published between 1990 and 1999. If you move forward in time to the papers published in 2000 and 2009, what you see is that the left side of that graph sort of collapses. In the 1990 to 1999 cohort, if you were working on 0-year-old ideas and you proposed in the NIH, you had a pretty good chance of getting funded. In the 2000-2009 cohort, you needed to be working on 7- to 8-year-old ideas to have the maximum chance of NIH funding. We have become too conservative, is the word, risk-averse, too punishing of failure. Again, let's go back to Silicon Valley. You have a portfolio of grants, of projects that somebody has funded. 49 of them, let's say you fund 50 projects, 49 of them fail, and the 50th becomes, Google or something. That's a very successful portfolio. What I would like to see is the same kind of thinking brought to the NIH. If a portfolio of funded projects, 99 of them produce nothing of value because it's just the ideas that were interesting ex ante, but ex post turned out not to work. But the portfolio as a whole solves type 1 diabetes. That's a successful portfolio in my view. If it solves Alzheimer's, if it makes huge advances in the well-being of people, I want the portfolios that we have to be evaluated not on the success or failure of any individual part of the portfolio, but the portfolio as a whole. Does it actually meet our mission of advancing health for the American people and for the world, right? Advancing longevity. That's the way we should be asking the portfolios to be constructed. And put in place, this is another of my heroes, is Max Perutz. Okay, I got too much to talk about. Let me just say about Max. He was a student, and for 10 years, in Cambridge University, and for 10 years he was asking, what's the structure of myoglobin? All his colleagues were telling him, all his advisors were telling him, you can't do this, go do something simpler, think smaller. And he just ignored them. And eventually won the Nobel Prize for figuring out the structure of myoglobin with tools that are just, primitive by current standards. The question is, do we have a scientific culture that would allow someone like Max Perutz to succeed? And if we're honest, right now, no. He would have failed out long before he got to the structure of myoglobin. Let me talk about the unified grant policy, and then I'll stop. Okay, so in order to implement this vision, there's going to need to be a lot of changes. But one of the changes, I think, is actually really simple. I'm going to give the institutes more capacity to choose scientific projects that they think are worth supporting. Previously, what happened, now, at the NIH, we are absolutely committed to rigorous peer review of the proposed scientific projects, right? So we have the world's best Center for Scientific Review that does an evaluation of the scientific proposals. That's going to be the heart and soul, continue to be the heart and soul of how we evaluate proposals. I've sat on scientific review panels at the NIH before for decades, and I'll tell you that we're really, really good at deciding if the methods proposed are interesting and good, but we're really not quite so good at seeing the promise in things that are not inside our portfolio. Like if there's new methods, new innovative methods that are not already in the published literature, we often don't do a good job of elevating them. And we're not very good as peer reviewers of saying, well, does the portfolio that we are excited about match the strategic aims of the institutes? Previously, about half of the NIH institutes had a pay line policy where they would get the Center for Scientific Review scores, you have a cutoff, and so you fund everything above the nth percentile, right? The problem there is that nth percentile often is too conservative relative to what the scientific opportunities that exists are. Institutes and centers have these fantastic strategic plans, 5-year strategic plans that they make. You all may have participated in sort of helping make some of them. But the portfolio that we fund may not match the strategic plan if you have a just simple pay line. So what we're going to have is a new funding criteria where the institutes still obviously have to consider scientific scores. Scientific rigor is still at the heart of what we do. But they will also be asked to construct their portfolio to consider other factors. For instance, does the proposal align with the strategic mission and strategic priorities as articulated in the strategic plans of the institutes? Right? These are not political. These are strategic plans about scientific opportunities that articulate every few years. Does the portfolio contribute to balance in the institute's overall research portfolio? Does it have sufficient, basic science research as well as basic, applied research in the portfolio? That balance often, scientific scores differ because standards differ for the scientific review committees, but it's really important that we fund basic science, applied science, the whole spectrum of science. And then third, the investigator's career stage and sustainability of the research workforce. We have, so I'm empowering the institute directors to choose a portfolio that matches the needs of the field and the needs of the people that we serve, which is the American people, the world, so that the advances, that the investments they make translate over to better health for people. Okay, thank you. I really apologize for going too long, but I really appreciate your time.
Thank you, Jay. If I had known you'd be willing to stay all day, but I do understand that you've got places to go, things to do.
I do need to run you all, but thank you so much.
Thank you again. I know that Dr. Bhattacharya gave you things to think about, certainly me. And I also know that he's interested in your ideas and has often said as much. So we'll get a chance late after the next conversations to talk together, talk with one another in sessions that are going to be coordinated by, moderated by our board members, Research America board members. We'll get a chance to discuss not only Dr. Bhattacharya's vision, but also some really interesting new data. And to show you all about that, I'd like to welcome to the stage my Research America colleague, Jenny Luray, our Senior Vice President of Strategy and Engagement, to fill us in on some new things that we've found out. Jenny, over to you.
Mary. Good morning, everybody. I don't think I need the box that my former boss, Senator Mikulski, used to carry around. Hopefully you can see me. I'm going to spend the next 15 minutes or so sharing public opinion data that Research America has commissioned. Some comes from our annual January survey, and some of it's brand new. Consider this speed dating. with our survey research. And our upcoming panel includes one of our pollsters who will be able to speak to the research in more detail. So Research America has been conducting public opinion research for over 30 years to understand public sentiment towards medical and health research and science broadly. We've looked at public views on specific issues like maternal health and clinical trials, as well as how the public views research in specific states. We're guided by President Lincoln, who said, "Public sentiment is everything. With public sentiment, nothing can fail. Without it, nothing can succeed." And for you lab scientists out there, I heard this saying recently: the p-value that matters most is public value. I also want to add that it takes advocates like you to bring public sentiment to the attention of policymakers. You're the ones who give the public a bigger voice, and for that, we salute you. You can find our surveys on our website. Here's the QR code, easy to find on our drop-down, and you can also read about our methodology. So I'm going to share what I call our good news findings, not a complete list, but some top good news findings, and then I'm going to also share some concerning findings. So we have found over the years strong bipartisan support for basic research. You may be wondering, well, how does Research America define this basic research in their question? It goes like this: even if it brings no immediate benefit, basic scientific research advancing the frontiers of knowledge should be supported by the government. And that has been an overwhelmingly bipartisan answer for many years. The other two questions have also received great bipartisan support, that it's the job of scientists to inform the public and policymakers about the impact of the research, with emphasis on the job of scientists to do that. And that scientists are trusted more than any other profession except doctors and nurses. Now, we've all been reading about differences in trust in science, and there is a growing gap, but scientists are still highly trusted by folks of all parties. In January, we posed this question: is it important for the President and Congress to assign a higher priority to medical progress? And you'll see that it was a very bipartisan response. You may be wondering whether or not this bipartisan sentiment has changed. I'll come back to what we learned shortly. It would be a disservice if we didn't also share concerning and even alarming findings. The last one, regarding Gen Z support for science, is a more recent finding dating from 2021, and we took a deeper dive, which I'll also share shortly. So let's take a closer look at the invisibility issue. This has been a problem since we started asking this question nearly a decade ago. Only 33% can name a living scientist. And only half are aware that research is conducted in every state. I want to be clear that we're not blaming the public for this. We actually feel it's the responsibility of the science community to address this issue. And that's why we've been supporting public engagement initiatives, like the two that you saw showcased by our awardees this morning during breakfast. Check out the civic science dropdown on our website for more information. Early career scientists across the country are building important connections to their local communities, and we all need to do more to support them. If any of our awardees are in the hall right now, please raise your hand so we can commend your work. This work is key to how we're going to address the invisibility issue and make science more visible. Another troubling finding over the last, since 2020, is the drop in those who believe the work of scientists benefits them, particularly the growing divide between those with different political affiliations. We wondered, could this also play into public support for medical research over this past year? And again, we'll be turning to that in a minute. So I'm going to share with you some of our deep dive into Gen Z. Why do we care about Gen Z? They're our future taxpayers. Well, maybe not my daughter yet, who's 24 and not paying a lot in taxes. Hopefully, she will be making a greater contribution to our tax base. But not only are they our future taxpayers, but they are current and future consumers of scientific and evidence-based information. They're an incredibly important demographic to support science. And this led us to delve into how Gen Z views science with help from Eric Zimmerman from Quora. And I'm so pleased that Eric will be joining our panel. This is the first time this data is being presented. What we saw in 2021 was that Gen Z was less likely to believe in investing more taxpayer dollars to support US science and technology, to think it's important for the US to be a global leader in health research, or to be concerned about China surpassing the US as a leading science and technology power. So let's see what we found. Well, the good news is that Gen Z is indeed supportive of science. Large majority believe government should fund scientific research and that it should be increased. But the story is not that simple. Gen Z does not see American global leadership as a reason to support science. As you can see, that was the least popular of all the reasons to support science. Young people do see relevance in science. But this relevance is concentrated around personal health, both physical and mental health. That is the big area of concern. Now, we might say, wow, that's so self-centered, but how many scientific disciplines now are playing a role in what we're learning about physical and mental health? I'd like to challenge the science community to take a whole range of scientific disciplines and let's meet Gen Z where they are. Let's relate those scientific disciplines to the knowledge we're gaining about our health, our physical and mental health. The biggest obstacle for young people isn't disinterest, but it is distrust. So among the most common concerns with scientific information, that the information might be biased, they're not sure if the source is trustworthy, or if the information is accurate. The findings on this slide raise a related challenge about how do we communicate scientific information to Gen Z in a way that is trustworthy. Interestingly, academic journals were considered particularly trustworthy by this age cohort. Is there a way we could reimagine those journals for this information age and for this younger demographic? I think our panel will touch on this. We commissioned research to look at Republican and independent voters' current views towards medical research. As you recall, they were less likely to see science as benefiting them over time, but they also agreed with Democrats in January that medical research should be a higher priority of the administration and policymakers. Would the administration's proposed cuts to research and other pushback on science impact their opinions? Ashley Warren of Harris X assisted with this research. Unfortunately, she fell ill and will not be able to join our panel, but I will share some of what she learned. So here's the good news. Medical research and NIH continue to be highly regarded by both Republican and independent voters. Medical research generally, 82%. When we ask specifically about NIH, that drops to 61%. It's still a majority. It's important to note that we often wonder, do people recognize NIH? Do they know what NIH is? And only 21% said either they had no opinion or they were unfamiliar with NIH. I think that's an important finding. So that's 80% were familiar enough to have an opinion. And I'll note that the CDC was slightly more familiar to these respondents and had a similar favorability. It also turns out that few of these voters believe the US is spending too much on medical research. We did look separately at moms and seniors because they're the most active consumers of health and they make a lot of the medical and health decisions for their families. And note that they were more likely to say, we're not spending enough. By large margins, all groups, that is, our Republican and independent voters and the moms and seniors who are part of those groups, they all believed that the federal government should pay for medical research. This is also an important finding because we wonder, does the public understand who is paying for basic research, for medical research? And clearly the federal government is recognized as that payer. I'll note that I think it's interesting that the second most popular choice for moms was state government. And we know that there are some states like Texas that have referenda that are being prepared around medical research funding. Also, seniors, their second choice was the private sector. So, in closing, our research led us to some insights about communicating the importance of federal funding for medical research outside of the Beltway. And I certainly don't in any way want to disparage the critical search for cures for so many of the diseases that still ail us. But the public is eager to hear about treatments. They're somewhat skeptical of cures. So I think that's very telling and gives us a lot of room to talk about everything from immunotherapy to imaging. They want to hear about well-known medical treatments, tests, and devices. They also are concerned about how changes in medical research funding could impact healthcare services. That's a greater concern than job loss. I think in part they think researchers are paid a lot more than they really are. And there's a great concern about local impact. And here's where the response is very similar to Gen Z. Local impact matters more than global competitiveness. So thank you for giving me this opportunity to share our research. You can find most of it on our website. And now I have the great privilege of welcoming our panelists to the stage, who will take what I've shared with you a few steps further. So today's moderator is Dr. Celine Gounder. Celine is the medical contributor at CBS News and editor-in-chief for public health at KFF Health News. She is also a member of the Research America board. Celine is joined by Cheryl Yeager, a principal at Crossroads Strategies, and Eric Zimmerman, who's the vice president of Quadrant Strategies, and as I said, was responsible for our Gen Z research. I'm going to be doing my best to fill in for Ashley Warren, the vice president of Harris X, who did our most recent research. All right, let me pull my things together and join you all.
Good morning, everyone. We're here because science does not happen in a vacuum. It happens in the context of public opinion, politics, and trust, or sometimes mistrust and distrust. The public's perception of research can shape everything from which policies get traction in Congress to whether families decide to vaccinate their kids. So today we're going to focus on three big questions: how public opinion shapes research priorities, what the public cares about versus what policymakers actually fund, how we address skepticism and misinformation in an age where social media outpaces traditional sources of expertise, and how we can engage the public as partners in science, not just informing them, but creating real dialogue and engagement that builds trust and relevance. So I am going to skip over the introduction since Jenny already covered that. I'm hoping this will be a candid and solutions-oriented dialogue with input from all of you as well. So Cheryl, how does public opinion shape what policymakers prioritize? And how should advocates for scientific research use data, translate data into action across the aisle?
Well, it's great to be with you all this morning. Just for a little bit of background, I worked on the Hill for 15 and a half years as a Republican staffer. And so we're starting with me because, of course, right now, DC is controlled by the Republicans, obviously the Trump White House and, and in Congress, both House and Senate. What I thought was interesting about the slides and the focus on what do Republicans and independents who delivered the election results for who's in charge right now, why those are so important is you need to understand who's making the decisions and how you have a conversation with them. And so when we talk about things like public opinion, that's broad. And so public opinion is always, important for like large context. But when you're talking about policy decision makers and who really has the pen to legislate what the levels of funding are, or the leadership position, like Dr. Bhattacharya, an election determines that. And so what I think is important is how do you translate this public opinion and make it personal so that it goes up from the ground up to the members of Congress who vote and make decisions on this, as well as the administration decision makers in the Trump administration right now. And so this information broadly, seeing that people are supportive, is step one. You haven't had such a dramatic shift, even if the Trump budget made it look like there was a dramatic shift. You had Congress come back with the leadership of Senator Collins and the leadership of Congressman Cole as the chairs of appropriations, with Aderholt and Capito, Katie Britt on the Senate side, leading a huge Republican letter to say not only does money need to go out, but we're going to keep NIH at higher levels, even with called for cuts in the overall federal budget. That doesn't come from just what do people think about science? That comes because they're hearing about it in their states and their districts. And so I think that is where all of us here, when we're talking about how do you regroup on what's been, I would call it the COVID hangover, the science hangover that's sort of tainted who do I trust with the science information, it starts there. It starts from the community and going up.
Eric, what do Gen Z audiences care about, and how are those opinions, those thoughts, getting to elected officials, if they are at all?
Yeah, it's a great question. I think like most audiences, what Gen Z cares about the most are their aspirations for their own life, the kind of person that they want to become, the kind of career that they want to have, the type of lifestyle that they want to lead. What we found in our research is that, I think this is no surprise, coming of age during the pandemic, during a time of intense political polarization and social polarization, they're focused on interpersonal connection. They're looking to form connections with their friends, their families. They're focusing on thriving personally, feeling well themselves. And so when they look at the impact of research, what they're hoping to see is the way in which research will enable them to understand the people around them, to feel well themselves, to have meaningful, healthy relationships with their family. That was very interesting in our study that the types of science that Gen Z is most interested in order, are psychology, mental health, behavioral science, and neuroscience. Unsurprisingly, all of those directly have to do with understanding the human mind, why we feel the way that we do, how we can understand other people who feel differently or experiencing conditions that we don't understand. And I think what that tells me about how we communicate about science is we have to start with where Gen Z is coming from. How is this research actually going to have implications for how they feel about themselves, for how they feel about their family, and whether they're able to achieve the things that they want to in their lives?
So for all of you, but let's start with Jenny, how can policymakers and advocates use this data, the data on moms, the data on Gen Z, to frame the research in a way that it's not so abstract, that it's more meaningful to people's health concerns and their lived experiences?
I think a lot of this comes down to storytelling. And I know a number of you are in the audience are working on stories in your specific areas, whether you're a disease advocacy group or scientific society, that storytelling, which some people scoff at. Why are policymakers making decisions based on stories? It's the stories that bring the facts to life. Yes, the facts are important, and one of the things that Ashley found in her research is that the public wants facts. They don't want just the stories. So the best sort of package is, both for policymakers and the public, is the story and then the facts behind that story.
And I'll just jump in as somebody who's also a journalist. I think sometimes there's confusion about what is a story. And at least in my business, the strongest template, so to speak, for a story is what we call the hero's journey. And unfortunately, it does not always fit preventive public health programs very well, so that's a very big challenge. But the hero's journey is, well, imagine the movie Star Wars. So you meet the hero encounters a challenge or a problem, hero overcomes the problem, and it's a happy ending of some kind. And it can be very challenging to frame some of these issues, the research, using that template, but it is definitely by far the most powerful in terms of that kind of communication. Cheryl and Eric, do you have anything else to add to Jenny's comments?
Well, I would second what you mentioned about the hero's journey and the struggle of kind of inserting individual agency when it comes to, well, for example, public health research is often a big challenge to do that. But if you kind of look beneath the surface, I think there are often ways to do that. Identifying, for example, an individual inside of a bureaucracy or a public health system or a community who is noticing a particular problem and who enlists others to help. So we just have to look for maybe a slightly different hero than who we are used to, but there are definitely angles to do that. And it's hugely important that when people evaluate the frame of research, they see individual agency. I think one obstacle we're often up against is that scientists, especially in public health, but not only in public health, are seen as ignoring individual agency, and it's really important to demonstrate that's not the case.
I just want to add, I really like how you both put that. And one of the things we're doing is we're really encouraging members of scientific societies to really tell those hero journey stories. Mm-hmm. Now, many of them are not yet at the aha, but there have been little ahas over time. And so how do you tell that in a way, right, that speaks to that hero journey frame that we all yearn for? And I think scientists can really do that. But they need some training and they need some resources, but that's inherent in the research process. Yeah. So let's tell those stories.
I mean, think about the story of Erin Brockovich, right? Which was essentially a public health issue. Just one other comment on this before we move on. I think very often we think about, well, we don't want one person to represent. This was a team effort. But for the storytelling, you actually do want that one person. And that may not be fair in terms of credit, but that's the better story. And the other thing I would say about professional institutions, who I hear from a lot, I don't want to hear from your CEO. Very often their PR folks come to me and say, do you want an interview with their CEO? No, what you guys need to be doing is finding the people in the community who can tell the story, who can be the story. This is a question for all of you. What are some of the most effective strategies to build trust and overcome some of the skepticism we're seeing, particularly among Gen Z, skepticism about whether the science is credible and trustworthy?
Well, that's a great question. I think what we found in our research is that Gen Z is looking for two things. They're looking to be entertained, and they're also looking to hear from credible voices. Those often don't go hand in hand, but it is part of sort of the Gen Z experience. When we ask them, where are you encountering, where are you learning about scientific information the most? The top two sources were YouTube and TikTok. But when we asked, who do you trust the most? It is their doctors, it is scientists, it is professors or teachers that they have in their academic institutions. And so they are sort of struggling, if you look at this data, between what they find entertaining and who they trust. And so I think it's sort of on us in the scientific community to help bridge that gap by frankly becoming more entertaining communicators, by becoming authentic communicators, by maybe feeling more comfortable communicating about science in a more casual, kind of unbuttoned environment that goes beyond the constraints of kind of peer-reviewed journals and meets Gen Z audiences where they are, which is online with authentic, personally relevant stories about the research and how it affects their lives.
So I was really thinking about this on the drive-in this morning, especially because I think about it on a personal level. Like, how do I keep up with the news to be on top of what I'm trying to consult our clients about what's going on here in DC? And there's just so much influx of everything. How do I know what to trust, especially in an AI environment where even when you type into Google, they give you answers that only if you know and can peel back, are those accurate or not? Did you ask the right question? And I think, we're in this era that's evolving for journalism and trusted sources of how do you have so much information and now curate it? When I was growing up, because I'm going to age myself here, we used encyclopedias, right? And then you have Magic Google now and everything else. So who's curating that data, and how do you actually get more data out there to more people because they have different sources? I think something's very interesting is happening right now in politics here in DC, just to bring it back. When I was on the Hill in elected leadership, working with different administrations, both sides of the aisle, there would be times when you wanted to have buy-in from Congress to help create an echo chamber where you would talk about whatever new initiative the White House wanted to roll out. And there would be these embargoed briefings, and you'd have this heads up, and they would want your boss to have a pre-prepared statement, and it was all ready to hit go. What we've seen over the past 9 months with the Trump administration is this White House doesn't trust, I wouldn't say any, but the vast majority of major news outlets are not the trusted curator of their information. They're not going to Congress and saying, back up my position. They're out first. They're out making the news. And I think that is a very distinct environment, as all of us here are talking about how do you influence science policy. If the Trump administration is not building that echo chamber but wants to be the first voice out, then we all need to think about, okay, they're the first voice out. Who are the curators that different populations, depending on age, politics, maybe they like sports podcasts and they get their news through their sports podcasts. Maybe they're more like me, and I like to see where I'm going to travel next, and I get some of my information there. But there's science involved in all of these things, and how do you incorporate it into the spaces that people want to read and hear about? And that is a new task, I think, for everybody as they're trying to communicate.
Jenny?
Well, putting privacy concerns aside, it turns out to be not that hard to figure out who's listening to who and who's watching what. And so one of the things Ashley found in looking at information sources, and I think you'll appreciate this, is that Republicans overall watch Fox. Independents are watching CBS. Moms were watching ABC. Now that's in terms of TV news. When you can also look at what people are following online. Podcasts are very popular. YouTube is the podcast channel of choice, which I found interesting. So I won't go into the other things that we found, but the point is that for those of us who are advocates or even who are newsmakers, policymakers, or folks who are really utilizing news channels, there's data out there, and we can reach people where they are in that way.
So I want to provide a little bit more context for some of the polling you have done. So for the first time, Gallup polling found that social media, this is from this year, social media now outstrips TV news as the primary source of news for people in this country. And that is more so, not surprisingly, with people who are younger, but across the board, that is the #1 source of news. Secondly, you have, some of you may be familiar with the Edelman Trust Barometer. And what we're seeing in the Edelman Trust Barometer is a shift away from what I would call top-down trust. So trust in elites, experts, institutions, the legacy media, and a shift in trust to what I would call lateral trust. So you could think about it as concentric circles, family, friends, and peers, and then people you see on social media. And so yes, as individuals, you might trust your personal doctor the most. I think about it as force equals mass times acceleration. The fact is, when you're getting bombarded with maybe somebody you trust a little bit less, these social media influencers, you're exposed so much more, the masses so much more. And so the impact can actually be additively more. So in that context, how do you think about the way in which scientists, researchers, people in the medical professions and public health should be trying to reach out using social media?
Well, that's a great question. I mean, I think, as I mentioned, the data earlier shows that scientists have a hugely important role to play. And I think in the long term, the solution to the trust problem that we're in right now, or this dynamic between entertainment and trust, has to do with more credible voices showing up in more entertaining platforms, so social media. So I think strategically, it is hugely important that scientists are visible and active and engaged on social media. It's easier said than done, right? So I think there are a few, overarching principles for how to do that. The first is just to be authentic, to be yourself. I think as, scientists tend to have an inclination that my expertise and my academic background are my calling cards, and so I am gonna lead with statistics, I am gonna lead with my degrees, I am gonna lead with the studies that I can show you to prove that I am right. I think that's often a trap because it's very impossible, if not difficult, for the lay audience to actually understand what we're talking about. And when they don't understand something, they tend to either tune it out at best or be skeptical of it and assume that we are trying to trick them at worst. So I think we need to, I say this not as a scientist myself, but I would advise scientists to be scientists, but to communicate like human beings and communicate as you would for any other subject, and know that your identity will help provide your credibility. You don't have to back that up with sort of a technical style of communication.
Yeah, I think people trust people who are like them, and so the more you can communicate who you are, I think is very helpful. But people who are like them or people they aspire to be, and so lead with that. Excuse me, Jenny?
Oh, I'll just add that, Research America and many others of you, we believe strongly that communication training, not delivering your paper necessarily to a scientific audience, yes, you need that training, but communicating to the public should be part of STEM training. And with the digital natives who are now in our PhD programs and our master's programs, wow. Can you imagine what the positive force that could be unleashed if these young scientists were given the resources, some skills to really get out there? I think we could really make a difference, but it has to start within STEM training. And I know Keith Yamamoto, a long champion of science communication and training of PhD students in this way, would certainly agree. And I also know that this is something you're working on, Celine.
Yeah. Which I'll talk about during the coffee break with people if they're interested. But one of the issues we're encountering is also a misunderstanding of what is the scientific process, and it is a process, right? It's not the Bible. It's not a fixed body of knowledge that doesn't change. How do we communicate what is the scientific process? What is scientific consensus, which also gets confused with groupthink? How do you communicate those concepts in a way that people understand?
Well, I'll give it a shot. I think that the risk here is creating unintentionally an us versus them mentality, where we come across as suggesting all of the smart people believe this, and so if you disagree, you must not be in part of that group. So I think the first step here is a matter of tone, or when we're communicating about scientific consensus, we don't want it to appear defensive or condescending. We want to acknowledge why people have questions or concerns about what is often being taken for granted, and to understand, of course, that they're not nearly as steeped in this information as the scientists communicating about it are, so to approach it humbly. And I think while the temptation is to point to overarching statistics, I think, Celine, to your point earlier, I think it is often stories or anecdotes or examples that do the best job of reinforcing why a scientific consensus has come to be the way that it is. Examples of people who are affected, examples of the experiments that have been conducted that have reaffirmed it. I think the more specific and tangible and individual we can be when we're describing a scientific topic, the easier it is for people to embrace that story. So I think it's humility and sort of an interpersonal style of communication. Those don't always lend themselves naturally to the idea of scientific consensus.
So I have a couple of thoughts here. I think Dr. Bhattacharya hits on something about reproducibility. It's not just that something's settled, but that you have more data sources so that no matter who your trusted source is, that you can go to that person and know that you've got the right information. I also think about it a little bit in retrospect, not to bring up COVID, but let's bring up COVID. When people were hesitating to trust the changing information, rapid speed appreciated, obviously, during a pandemic, that information changes, so please hear what I'm saying. But the changing positions about what was safe and what was not safe, it's interesting what states like Massachusetts did with the startup company BioBot Analytics, was able to track SARS-CoV-2 in wastewater. And then the governor at the time, who was a Republican, made wastewater data one of the sources that individuals could then decide what was their risk to go do something. That's a totally different data source than the data sources that other states were using. And so I want folks to think about it a little bit like this. Mandates and being told that this is how things need to be done, there is a knee-jerk reaction across the board to that type of approach of leadership. And so how do we all, as leaders in science, and knowing how important science is to improve the health of the United States and the world, how do we recognize that, but also work to deliver different types of data sets that will identify, that different folks can identify in their own perfect curation. I just think we need to be thinking less about one source, one peer review, one thing, and more about how do you share this data across different platforms so that you have, whether it's entertainment or not, you have that distinct touch. And just one more thought, just to wrap this up with Dr. Bhattacharya, because I've been thinking about this too. We were talking about it in the back room. But he highlighted that since he came in as director, that half of the ICs were still using pay lines, and they weren't always applying what they were funding to strategic plans and initiatives. I think that's really important for folks to think about. I mean, I don't know if his half is half of the budget of NIH, but that's probably a lot of billions of dollars since we fund NIH at such a high level. Money is important, but money strategically directed is also key in science, just like we're talking about how you communicate. And so I think we have an interesting time with this new director trying to think about, I want to think about strategic plans and how we're translating science in a way that really helps change people's lives. And so I think there's a communication strategy here in advocacy with what he's trying to do internally at NIH and how we need to think about how we're talking about science and building support for science and scientific funding.
Cheryl, to follow up on that and pivot a little bit, how do lawmakers and policymakers think about challenges like mis and disinformation in health and science and medicine? And how should that influence the way we talk about it and try to communicate about it?
That's a hard one still. It's America. So, I start with, America is the land of the free. And you may not agree with everyone, but people are free to have individual expression and thought, and we can talk about free speech in a whole different context too. But I do think, I'm trying to come up with the right words. You're not going to please the entire room. Just like many people in this room are like, what is she talking about? That's fine. You need to know your audience, and you need to know how to communicate with your audience. I also think that a mistake that's been made in politics right now is that people are not talking both sides. You need to understand when someone doesn't agree with you, what are they disagreeing with you about? What is it? Can you find one commonality with that person to try to bring it back? And so, I think it's not always about, you were talking about groupthink. It's not always about how can you convince this entire group of people to do this. It takes one to start a movement. And so sometimes I think we're go fast, get this entire group. If we could only get these people in line, everything will be good. There's sprints and there's marathons, and there's a reason that we award both. So
I appreciate what you're saying, but I want to acknowledge that our information environment is ruthless and chaotic. And there is a lot of misinformation, which is actually disinformation. Disinformation, which is incorrect information being spread intentionally. Often people then pick it up and spread it because they think it is real information. That's misinformation. But the disinformation, there's no question whether it's, folks outside of the US who are spreading disinformation for political purposes, or folks internally who are doing so. So I do think we have to acknowledge that Research America and others here helped us, and AAAS helped to stand up something called the Coalition for Trust in Health and Science, which has been working with a whole range of clinical groups and scientific groups to help people understand what are some of the tools that we can use to combat disinformation, like pre-bunking. So you can check out that website. But it's a big, big problem. And it's one that we're really not addressing from a policy perspective.
Well, it's challenging because it's essentially a tool to either profit profit, you could say financially, or profit in terms of your politics, right? And so by its very nature, it is political. How do we move from simply informing the public to engaging with them in a real dialogue? It was interesting, some of us here were at a meeting over the weekend, the One Mind meeting on neuroscience, and I was talking to some of the researchers about something called community-based participatory research, and they had no idea what I was talking about. And the idea that and they were sort of like, oh yeah, we'll engage the public, we'll let them know what we're doing, and I said, no. You should be having them, at least in this type of research, engaging with you to determine what are the questions, what are the methodologies and interventions. I think there's something similar to be said about communication. How do we actually engage as opposed to just projecting messages at people?
Well, I think you hit the nail on the head. It comes down to actually listening to what people want. I think we often think of, listening to the audience as how can we demonstrate that we're listening, or how can we message that we're listening? And I think it really comes down to actually setting up forums and opportunities and channels to listen to them, to participate, to help them feel like they are part of the process. If they are patients, to understand what symptoms bother them most, or what lifestyle restrictions they are struggling with that they would most like to see resolved, and kind of building, the design around that. And I think people have pretty good radars for BS, and so I think worse than not listening is pretending to listen or engage and pay lip service. So, I don't have the secret sauce here, but it is actually authentically caring about what the audience wants for this research and building it around that.
And there's a growing movement, which our public engagement initiatives are part of, but it's a really growing movement around the country. And again, we're trying to get public engagement really to be more embedded in academic culture, which it really isn't right now. How do we create incentives for early career scientists, mid-career scientists, tenured folks to really go out and do this work? One of the groups we funded in Oklahoma, they came up with an Ask the Scientist. They went to their local farmer's market and put up a sign. Well, the young scientists could not wait to do it. The tenured faculty, one in particular, said, well, what if I can't answer the question? And the early career scientist said, you have a PhD, you read all the time, I can guarantee that you will be able to answer the question. But they were very focused on, what if I don't know the precise answer, as opposed to the dialogue, right? Because in a sense, that's what really matters. It's not necessarily, are you delivering, are you putting the decimal place in the right point, but did you create a dialogue? Did you come off as real, right? And that's, that's in part what these programs are trying to convey to communities.
Well, and saying you don't know, that's real.
Or saying you don't know, and right, exactly. There you go.
I want to follow up more on this discussion in terms of how do we incentivize this. I do think there is a risk averseness that you're touching on, a reputational risk averseness among the individuals, but also institutions. And as somebody who has been working in this space for long enough, I can tell you the academic medical institutions I've worked for have found this to be a real problem that I do what I do. They're very afraid of what this will mean for their reputation, what I might say, what it can mean for funders, for NIH grants, et cetera. So my personal way to approach it is I need to be ready to walk away from any of those at any time. But that's not necessarily an option for people. So what can they be doing within their own institutions? And what should institutions be doing to facilitate, to reward, to incentivize? And how can we convince them this is something of value?
The first thing that I would say, and this is a big culture shift, is to think of communications not as tangential to your mission, but as fundamental to your mission. I mean, communications is nothing more than thinking about what you want to achieve, who you need to motivate in order to achieve that, and then what would motivate them to do what you want them to do, and pursuing a plan to communicate that to them. And so I think the shift is thinking of communications not as a risk, but as core to the function of your mission, as the research you are doing themselves. Because if the research doesn't go anywhere or doesn't get funded, then it might as well not have happened. So institutionally, I think it's a culture change to communications being much more front and center to the goal of the organization.
Most universities have an office that is a community relations office. The STEM faculty and students tend not to be connected to that office. So there is a precedent, right? That's one way in. And universities, public and private, are looking for ways to show value to their local communities. This is a way to show value. It's not something to be necessarily scared of, in fact, at all. It's something to really develop. And there are universities around. Wisconsin is in the forefront here of actually creating some incentives for faculty to get involved. But we have a long way to go.
Yeah, I mean, my experience is media relations is very controlling. They don't want, and I've been asked to give, resident lunch conferences, et cetera, on how to do communication. And there will always be some senior faculty person there to quash the idea that they can go out and do this on their own. Oh no, you have to go through the media relations person, and they need to approve, and they need to connect you. And first of all, that's not how social media works, right? I do think, to your point, there needs to be some reframing and some new thinking about how this is done. I do want to turn it over to the audience to ask us some questions, to ask the panel questions. But let me perhaps ask one other question while we're waiting for all of you to come up to the microphone. There's one here and one here. You mentioned Wisconsin, and maybe you can elaborate on that a little bit more, Jenny, but are there examples, whether it's in medical institutions or other grassroots efforts, of how to do this kind of outreach to communities, engagement with communities, online communities, not just in real life, that you would point people to as examples?
Well, again, during COVID, our civic engagement microgrant program was fully online, and you can see what we did, what I didn't do, but what these early career scientists came up with, just really creative approaches, including even doing science experiments at home with K through 12, all done virtually. Another group to check out is the Society of Technology Centers. It's ASTC, so that's the association that represents science museums. and technology centers, and they do some fabulous stuff with communities. All of our public engagement programs, every single grant we've given out, there are descriptions of those, so you can see the types of models that we have funded over the years.
Cheryl or Eric, did you have anything to add? No? Okay. Question over here.
Hello, thank you. My name is Mariah Locklear from University of Oklahoma. When you think about the vast majority of the history of science, it has only been done by the elite, right? Mm-hmm. I mean, I think my undergrad physics building only had one bathroom per floor because they didn't need women's bathrooms when it was built, right? But science has never been more democratic than it is right now. But it almost seems that no one understands, right? There was no criticism of the 1920s research, but now the scientific community is under attack by that term elite. So I just wanted to know if that's just a fun coincidence or if there was a perspective you had on that.
I think the scientific community is allowing too few scientists to be their spokespeople. And so I agree with you on your democratic approach, which is why I started this panel with, if you really want to know how to advocate and grow science, start from local. Start from the local. And I think some of the campaigns that are being done to raise awareness are recognizing that, you know, with scientists talking about, I grew up in this area. I went to this school to be the best in this whatever your degree of science may be. And what I'm doing now applies to my family because I'm working on something so that we can better understand why my grandmother has dementia, or name whatever the disease is. But I don't think scientists are naturally communicators, and so they rely on core spokespeople. And so that's what we were just talking, having a sidebar here. There is a lot of misinformation out there, but I come from the perspective is there always will be. I cannot control misinformation, and to think that you can control the flow of information in a free society is contradictory. What you can control is how people value the information and how it's curated, and that's, I think, stressing about misinformation, and half of social media right now is full of bots. Mm-hmm. And I actually thought one of the most distressing things in the polling was that Gen Z didn't care about America being the leader in science. I think that's hugely problematic for democracy in the world. Broadly, because, when, people are always like, is democracy at risk? And I was like, absolutely, but part of it is based on our core values here in the United States. And so not recognizing that America is a leader in science, I think also just really does impact much bigger issues. So anyway, those are my thoughts.
I want to totally second what Cheryl mentioned about a more local approach to communications. I recently did focus groups unrelated to this project, but similar in theme, about how to build support for the public health field generally at the state and local level. And what came across overwhelmingly in these groups is that the way that people think public health works is that the CDC hands down a dictate and everyone around the country scrambles to kind of implement it, regardless of whether it's relevant to that community or not. And they were kind of blown away to learn that public health usually happens from the bottom up. There are local public health departments that are from the community, that are experts in that community, that are listening to the community, that are spotting problems, coming up with customized solutions. And that really, I wouldn't say it completely transformed their understanding of public health, but it made a lot of inroads into showing that public health is kind of an authentic, small d democratic institution. And so I think to your question, the same lesson applies to science more broadly, is that this should not be seen as an elite, federal, national process. It should be a local, humble, bottom-up process.
Yeah, so just as maybe it was a mistake to have Tony Fauci and Rochelle Walensky, who I love, by the way, but having them be sort of the lightning rods for all communication, having perhaps more state and local health department people being the communicators, or in the case of academic medical institutions, does it need to be the CEO or the chair? What about having a trainee who's coming up, who's been involved in a project, being the face of it? This side.
Hello, this has just been a great talk. So my name is Nathaniel Rader. I'm a fourth-year PhD student in biomedical sciences at West Virginia University. And really the statement that really resonated with me was, I think it was by Eric, where he said, we need to start looking at communication as being a necessary part of the PhD process instead of just an optional route that people go to if they're interested in. And really, like, throughout my academic career right now, most of my scientific training focused on communicating results with other scientists, writing grants, you know, the more technical aspects of communication. And I really feel like myself and even other colleagues I've discussed, your first discussion with friends or family that have, you know, polarizing views on certain topics that you're, you know, very well researched in, I felt completely unprepared for those kinds of interactions. And I just think it's like interesting that I have required courses for learning how to communicate science to other scientists, but the universities really have nothing in the curriculum or class-wise that's preparing us for, you know, speaking to the lay public, you know, translating these results into something that isn't just data and figures, but actually a storyline that actually shows how you're trying to help them directly. And I just didn't know if you had any aspects on how we can get universities more engaged into kind of transforming the curriculum to combat these problems, because I know that most Gen Z scientists are pretty passionate about wanting to communicate our results and tell people that we're not doing this, you know, for a fat paycheck, but rather to help society. At least all the ones I know do that.
Yeah.
So yeah, but
So I'll let you in on a little secret. They don't know how.
yeah, that's what.
That's part of the problem. And during the break, the folks here in the front row, Mary, Sudip, Keith, and others in the room are, I know, very passionate about exactly this, so you should come and talk to them. But
I just wanted to, so the question about how do we get more universities to do this is pivotal, and I think Celine pointed out some really good people for you to talk to. But for your own, you know, now education, there's a gentleman right in front of you, Dr. Fanuel Mwende, who was funded by the Lasker Foundation. He's right in front of you, right there. He put together a database of programs around the country, many of which are virtual, that are science communication oriented. So check that out, it's on our website. So you can start building those skills while all of us work together to make this a part of STEM training. And also leave us your name, we'd love to be in touch.
Oh, yeah,
Thanks.
Of course. Thank you.
anyone else? Over here.
Awesome. My name's Mallory. I'm a postdoc at the University of Maryland. Thanks for a really interesting discussion. I really appreciated the opening remarks about conversation, but I'm kind of wondering when we have to use a different approach. In our first talk, we weren't able to ask questions, unfortunately. I heard a lot about how it's hard to be an early career investigator. I didn't hear any solutions, and I know that our NIH director defended a budget before Congress that would cut thousands of trainee grants. And people who are applying for postdocs a year after I did, there's like nothing. Like, this is existential. And so I'm wondering like what our professional societies can be doing and what other approaches we should be trying right now, because this doesn't seem to be working.
Well, there are many advocates in the room who are working on this issue, so you're certainly not alone. We've got Richard over here, my colleague Ellie Dahoney at Research America. So folks are very aware of this and very concerned and working on these issues. And I think you'll find a number of them in the room here. And please see us afterwards. We can also plug you in.
I'm just going to pipe in here with your societies. The societies, almost all the societies have government affairs. And it is the decision makers who decide. Congress decides. I will always argue Congress decides the ultimate power of the purse, although some of that's being litigated right now, which is why I make the joke for those of you all in the loop. But Congress decides the power of the purse, Article 1. But a lot of societies work with members of Congress that they know and that they're familiar with. And you need to ask the societies that you all are members of to get out of their comfort zone and go talk to people on the other side of the aisle. I lobby. It is my job. I am in the offices, and I can see very clearly as someone who worked on public health on the flip side on the committee, how few are going into the other side of the aisle. And so that is something that you can all take to all of your societies. You cannot engage in a dialogue if you don't start a conversation. And so only going to people that you trust is not how you bridge and build support for a larger group, which a larger group is needed for votes in Congress to set budgets and to really change that dynamic. And what you're talking about, to me, ties perfectly back to what I thought was most distressing in the Gen Z polling data, which is if people aren't going to go into science and they can't get access to grants and the age is going up and they're not seeing this as a pathway forward, that changes America's position in the world as the leader of science. So this is a much broader conversation. So maybe they can't understand the dollar figure, but there's a lot of Republicans in Congress that are worried about world positioning and Russian bots and how people are getting their data. So find something that you can agree on and go see Andy Harris from Maryland. He's on appropriations and he matters.
And we don't yet know how things are going to play out in Congress, right? So you have the president's budget, which has a massive cut to NIH funding, but what we see coming out of Congress is basically flat line, not an increase, not a decrease. So yes, that's less spending power, but it's not the dramatic cut that's proposed in the president's budget. So I think whether this is a long-term issue or whether some of this will turn around in the next couple of years, we don't know. Having said that, are there shorter-term ways to help postdocs, people who are early trainees, to survive that period? I was at a meeting last 2 days in Boston with folks from family offices and so on. Could each of them step up and say, we are going to support 1 or 2 postdocs for a year? That's very cheap labor, actually, to pay for. And so if you can start to advocate for that kind of bridge funding, I think that would help you and your colleagues significantly. Anyone else on that? Over here.
Hi, I'm Amas Richardson with the Association of American Cancer Institutes. I found the survey data really interesting in terms of looking at public trust in medical institutions. But I was thinking that, have we ever thought about developing the idea of trust further? Because trust, in terms of what does that mean? In terms of what does it mean to trust in an institution, and what does it mean to not trust an institution? I feel like right now the public kind of has a very binary way of thinking about it, in which either A, they blindly listen to anything that is told, or they believe that everything is manufactured and that they don't believe any of it. Have we thought about kind of developing that the biomedical research community has the public's best interests at heart, and that if we do get something wrong, that we are allowed to make a mistake and are still trying to do our best to serve their public interest?
I want to turn that to you. How do you think they should do that?
I think it's difficult. My background's more in philosophy and government more than biomedical research, but I think that trying to have the public understand that the research is coming from bottom up, I think, is a really big part of it. I think that, especially as Americans are generally very distrustful of overarching governments or just top-down delivery of instructions. So having it be in some sort of fashion in which the information is coming from community members, community first, and then also that they're allowed to say hey, this is still developing, we might make a mistake, kind of almost like a parent would in a way. If a parent makes a mistake, they say, hey, I screwed the pooch on this one, that's my bad, but I'm trying my best, something of that nature.
Well, that's also interesting in the context of what you were saying, Cheryl, earlier about a strategic approach, because that is much more top-down, whereas what we have now or historically may have been more bottom-up, where as long as you passed a certain level of scientific review, were scored at a certain pay line, it was excellent science, you were funded.
I think you need a combination, and that's what he was hitting at. And that's what I think when people judge what is an agency doing for me, that's part of the communication piece that's being missed. Are you just, what is the end result? And so I think to constantly think about what I love about advocating for science, and always have when I was on the Hill, is that you always get an answer. So every taxpayer dollar that you put towards science, you get an answer. You're setting something with an answer. I can't say that for all government-run programs. Just take a look. So, I mean, look, I don't believe that I am like far out there on this with colleagues, but I do think it's how you communicate the answers and the results, and that you're showing progress. I think the same thing, we talked so much about NIH and medical research, but Research America, I know there are alliance members in here, is broader than just the scientists at the university. It's also industry in translating and delivering that end product. And I think we're in a moment in time right now where even the science of industry is being questioned, and that is there's a lot of work to be done on communication here, but it starts on many levels. And so that's all I'm saying.
I think we have time for one last question over here.
Thank you. My name is Donna Cryer. I am the founder of the Global Liver Institute. And I wanted to highlight the work that the National Academies of Medicine has given to collaborative efforts by YouTube and the Council of Medical Specialty Societies on showcasing information that is trustworthy, giving better signals, and helping to identify individual physicians and medical society efforts on social media channels, and to raise their visibility. But I really did come to speak about some efforts that the Global Liver Institute has been doing just last weekend to
And just making sure there's a question.
Patients. So here's how can we expand efforts such as what I saw last weekend before we went to the Hill, which not only involved training patients in their storytelling and upskilling them, but what I loved was seeing the shift in the number of medical students and scientists who were engaged in learning how to tell their stories alongside patients before they went to advocate on the Hill, and the number of influencers that I saw in the corners of the hotels interviewing scientists and helping to help train those methods. And so how can we support those types of, we're doing that in digestive diseases and hepatology. How can we scale those types of patient advocacy organization-driven efforts to work with patients and scientists collaboratively to deliver their messages to policymakers?
Go ahead.
Well, it sounds like, I mean, not to be glib, but it sounds like you're doing it. And this, I think to me, this sounds like the solution, which is, authentic, credible organizations who have a deep relationship with both the patients that they work with, the scientists who are communicating on their behalfs, and have that type of relationship to lead that effort. And so I think it is really replicating the type of work that you're undertaking, which is easier said than done and takes a while and is a real bottom-up approach, but that's really what starts with it. And I think also resources like the ones that Jenny mentioned that are on her website. Another one I know that is great is a resource called Storytelling for Good, which is created by the Communications Network, which I had a chance to participate in when that was being developed, which is a really sort of straightforward, here's what makes a good story based on the hero's journey, here's how you communicate that story. So I think, I wish I had a better answer for how to scale this, but I think it's, keep doing what you're doing and encourage other organizations like yours to take up the mantle.
And Donna, I know you will because you're really great at outreach, but share your model with other patient groups. Let's try to avoid having to replicate things. Let's borrow from one another's creativity. So I look forward to learning more about that effort. It really sounds terrific.
Well, with patient groups, but also professional societies and organizations.
Exactly. Yeah, thank you.
Well, I think on that note, thank you for wonderful questions from the audience. I think we're going to take a break now. Is that right? Okay.